Hello everyone and welcome back to our videos. Today we will talk about some types of stabilities in accordance with the aircraft axes. And we will start with the longitudinal stabilities. To achieve a longitudinal stability, most airplanes are designed so they are slightly nose heavy. This is accomplished during the engineering and development phases by placing the center of gravity slightly forward of the center of pressure. What's the meaning about the center of pressure? Center of pressure is a point along the wing chord line where lift is considered to be concentrated. For this reason, the center of pressure is often referred to as center of lift. During flight, this point along the chord line changes position with different flight attitudes. It moves forward as the angle of attack increases and aft as the angle of attack decreases. As a result, pitching tendencies created by the position of the center of lift in relation to the center of gravity vary. For example, with high angle of attack and the center of lift in a forward position, the nose down pitching tendencies is decreases. The position of the center of gravity in relation to the center of lift is a critical factor in longitudinal stability. As we see here in this figure, the center of gravity goes forward. That means the center of lift goes to the aft. And in the second figure, we say the opposite. The center of gravity will goes to the aft. That means the center of lift will go to the forward position. Lateral stability. The second stability in accordance with the aircraft axes. Stability about an airplane's longitudinal axis, which tends nose to tail, is called the lateral stability. If one wing is lower than the opposite wing, lateral stability helps return the wings to a winged level attitude. This tendency to resist lateral or roll movement is aided by specific design characteristics of an airplane. The most common design for lateral stability is known as wing dihedral. What's the meaning of wing dihedral? Dihedral is the upward angle of the airplane's wings with respect to the horizon. When you look at an airplane, a dihedral makes the wings appear to form a spread out V. Dihedral usually is just a few degrees, as we see in this figure. Here we have the dihedral. This is the dihedral angle of the aircraft. The last stability is the directional stability, and this is stability in accordance with the aircraft axis. Stability about the vertical axis is called directional stability. Essentially, an airplane in a flight is much like a weather vane. You can compare the pivot point on the weather vane to the center of gravity pivot point of an airplane. The nose of the airplane corresponds to the weather vane's arrowhead, and the vertical vane on the airplane acts like the tail of the weather vane. High-speed aerodynamics. Advancements in technology have produced high-performance airplanes that are capable of very high-speed flight. The study of aerodynamics at these high flight speeds is significantly different from the study of low-speed aerodynamics. At low speeds, the study of aerodynamics is simplified by the fact that as air passes over a wing, it experiences a relatively small change in pressure and density. This airflow is termed incompressible since the air undergoes changes in pressure without apparent change in density. This is seen when a fluid passes through a fissure. As fluid enters a restriction, its velocity increases and the pressure decreases. At high speed, the change in air pressure and density is significant. For example, as air enters a venturi at supersonic speeds, the airflow slows down and therefore must compresses to pass through the restriction. Once a fluid compresses, its pressure and density increase. The study of high-speed airflow must account for these changes in air density and must consider that the air is compressible. The Mach number. The Mach number is the ratio of the true airspeed of an airplane to the speed of sound and used on the military aircraft. When an aircraft flies at the speed of sound, it's said to be traveling at Mach 1. A flight below this speed of sound is expressed as fractional Mach number. Types of high-speed flight. We have subsonic flight, and its flight below Mach 0.75 is called subsonic flight. A transonic flight, the most difficult realm of flight, is that the transonic speed, which is between Mach 0.75 and 1.20. Supersonic flight, flight between Mach 1.20 and Mach 5 is smooth and efficient. Flight speed above 5 are called hypersonic flight.